Yeah, hi everyone. Welcome again to the DeFi webinar series. I'll just outline what all we are covering in this specific part of the series. So here we are going to talk about the core components of DeFi system. And by core components, I mean the core construct or primitives that define the DeFi ecosystem. And just to recap on what we covered in the first webinar. First, we talked about what blockchain protocols are. We talked about smart contracts that are core construct of Ethereum and other EVM compatible blockchains, plus substrate and other non-EVM, non-substrate blockchains. We also talked about what centralized and decentralized exchanges are and how decentralized finance differs from centralized finance. Today, we are going to dig deeper and go into the core constructs of DeFi. Once you understand the core constructs, then you would be able to appreciate any use case in the DeFi ecosystem, because these constructs are applied as well as combined in various ways to power a specific use case. And I will be talking about some of the use cases also to explain a specific primitive. And in the time, do you have any question? And if you need further clarification on any of the topic, do let me know during the webinar. So you don't need to wait till the end of the webinar to ask questions. Just to a bit recap. So we talked about blockchain, that how blockchain is a decentralized ledger technology where the transactions can be done between two unknown parties, without any intermediary involved. And there is various components like asymmetric cryptography to ensure the integrity of data that is being shared or the transaction that has been made. Plus, there are miners or consensus algorithm through which all the transactions are posted into blockchain. Once the transactions are posted into blockchain, they become immutable using hashing algorithm. And so that's how you get to have transparency of transactions, integrity of transactions. And once the transactions are there, you have a historical train of transactions. On top of it, so this was what something Bitcoin looks like. Then we come to Ethereum. Ethereum adds the whole smart contract layer on top of Bitcoin kind of structure. With smart contracts, you can write logic, you can write different kind of transaction processes, and then they can be automated using blockchain. And based on the conditions defined in the smart contract execution take place. And then we briefly talked about oracles, where oracles are means to bring data from the real world into the smart contracts. So these were some of the core construct of the DeFi using blockchain, smart contracts, oracles, stablecoins, etc. So now we are going to jump into the other pieces to it. I think there's some formatting issue here. So first we'll talk about transactions. Now, transactions, if you have set up a Ethereum account, or let's say a wallet, so you see that, let's say you download a MetaMask wallet, and I would recommend everyone who is joining this webinar, they should set up a MetaMask wallet to see how wallet works. Once you set up a MetaMask wallet, what it consists of, it keeps your private key, which is used to signing the transactions. And it has got a public address that you share with someone to receive tokens into your MetaMask. Now, so when we say transaction, we say any kind of send or receive transactions of tokens. And in each of the application, there will be different kind of transactions that you will see. It may be a simple wallet-to-wallet transactions of sending and receiving tokens, but then you may be sending tokens to the smart contract also. And how this works is that in Ethereum, there are two kinds of accounts. So one is the externally owned accounts. Now, externally owned accounts are very similar to Bitcoin accounts. where you have a public address and you can receive tokens using that public address. So you can give that public address to someone who will send you a Bitcoin to that address. Now, these are externally owned accounts. They are outside the blockchain. But then when smart contracts came in Ethereum, each smart contract also has an address. So now you can do a transaction where you are sending tokens from your wallet to not just another wallet, but you can send a transaction from your wallet to a smart contract address. So now you have got two kinds of transactions that are enabled with Ethereum kind of smart contract platforms. And the best part is that since there can be any number of smart contracts. So if you are interacting with, let's say, a lending smart contract or a decentralized exchange or a prediction platform, any kind of DeFi platform you're interacting with, there can be numerous type of smart contracts, and still you can use your same wallet to interact with those smart contracts. And that's the beauty of it. It's a single wallet where you are not just using it to send and receive token, but you are actually interacting using that wallet with any kind of smart contracts and do transaction on those contracts. So for example, in a lending contract, let's say you want to behave like a lender. You want to provide liquidity or you want to lend some amount to the contract. So again, using your MetaMask, you can connect to the contract. You can send the tokens to the smart contract address in this case. And those funds will be custodied and you will get interest depending on what logic has been written in the contract. Now, each transaction in Ethereum accrues a gas fee. And the gas fee, as we talked about in the first webinar, is a very critical component of a blockchain system because gas fee is an incentive which is passed on to the miners who are mining the blocks, validating all transactions and writing those blocks into the blockchain. So each transaction, there's a transaction fee which is levied, and the transaction fee is used as an incentive. One interesting thing I would like to say is that how it works is, as you know, that there is a definite time when a block is written. In the case of Bitcoin, every 10 minutes, a new block is written. In the case of Ethereum, every 6 seconds, a new block is written. Now, what does 6 seconds or 10 minutes actually, why this time period is there? So the point is that transactions are happening every second, or even multiple transactions are happening every second. Now, it's not practically viable for a miner to take each transaction, authenticate, validate it, verify it, and then put it into blockchain. So rather than doing that, we have defined a time period. So like Bitcoin defined it at 10 minutes. So all the transactions that come into 10 minutes, they are all verified, validated, and then combined into a block of transactions, and then put it into blockchain. And these are block of transactions. That's why the term block came into the blockchain. And then since these blocks are put aside the previous blocks, forming a chain, that's why it's called a blockchain. So now there is a mempool, you can say a temporary storage, where all the transactions go before they are finally posted into blockchain. So when you are doing a transaction on blockchain, the transaction automatically does not go into the blockchain. The transaction first goes into a mempool, and within the mempool, then the miners are going to verify, validate. They are also going to share the transaction to other miners. So as you know, in blockchain there are multiple nodes. It's a network of multiple nodes hosted or deployed throughout the world. And so each transaction moves from one node to another node. They are synced up. Each miner get a chance to verify, validate the transactions. And so all the transactions remain in mempool before. So for example, in the case of Ethereum, they will remain in mempool for 6 seconds before the validated transactions, which miners choose to put into the block, will put into the block, and then they will be posted on blockchain. Once the block is published on the chain, at that point of time, you can say that your transaction has been finalized. A finality has happened, that your transaction cannot be reversed. Till the time it is in mempool, it may be possible that miners choose not to include your transaction in the block. It may be deferred for next block. And it happens. Sometimes, your fees is less and your transaction is not executed within the first 6 seconds or in the first block of Ethereum. So sometimes you may need to increase the fee. And that has happened, when typically some of the auctions happen. Let's say a new NFT auction is happening and people are are crazy about it. So it's like in the traditional world also, if there's a concert coming in and the tickets are booked within the first 5 minutes, so a lot of people are logging into the platform and buying tickets. Same way, when you are doing here, people tend to increase the fee, because once you increase the fee, then miner will have more incentive to include your transaction in the same in the first block that is going to be there. Otherwise, it may be deferred to subsequent blocks. There's another problem that is interesting here is that in the case of blockchain, now, as you understand, let's say, and I'll talk this later while we talk about a decentralized exchange. In a decentralized exchange, let's say you're going and exchanging a token. You want to buy, you have an Ether and you want to buy USDT. Now you're putting that transaction. Now the transaction also goes into the mempool. Now the point is that this mempool, all the transactions in the mempool are transparently available to anyone. Now, since these transactions are available to everyone, miner can choose to, can be biased or bias against any specific transaction. So this classical problem is called front running. It is illegal in the traditional world, but due to the transparency nature of blockchain, it is not illegal in legality sense in the case of blockchain. So front running is one challenge that comes in, especially when somebody can use your transaction and execute it first. So, but there are a few startups who have come up who are bringing in privacy of data within the mempool so that these transactions are not, you cannot read the transactions to see what exactly is happening. Front running is in traditional stock exchange. You must have seen that if, let's say, a very leading popular stockbroker does a transaction, everybody starts to do that transaction. Or sometimes, just by knowing the nature of the transaction, the price of stock can go up and down. The same problem can happen here also. Based on a large chunk of sell that happens, can drop the price, or large chunk of buy, somebody buying 500 Ether or 1000 Ether can kick up the price up, So, so this is another interesting aspect of transactions. So any questions on what typically transactions are in Ethereum and other blockchains with smart contract platforms? So one thing I'll clear. So there are two kinds of blockchains, and you must have seen if you go to let's say Solana or you go to Ethereum, their websites, you will see most of the time they write as smart contract platforms. So when we talk about DeFi, we are actually talking about only those blockchain protocols which have got smart contract platforms, or which are smart contract platforms also. Now coming to this second topic, which we had covered a bit in the last webinar also, that is the tokens, which is again, one of the core construct of DeFi. Token is, of course, the core construct of the blockchain itself, but a specific mention when we talk about DeFi is required. Now in DeFi, we'll talk about few type of tokens. Broadly speaking, we divide the tokens into fungible tokens and non-fungible tokens. So fungible tokens are basically which possess the property of fungibility. The tokens can be they are identical. They can be interchanged, similar to our currency, fiat currency, where 100 rupee note can be exchanged with another 100 rupee note, and there is a clear divisibility also. So a 100 rupee note will be equivalent to 10 rupee notes, right? Because they are identical and they are interchangeable. So these are fungible tokens. And Ethereum launched, one of the earliest interface Ethereum launched was ERC20 token standard, which basically defines how a fungible token can be formed. Now, what we mean by ERC20, this word is very common. You will hear it always whenever you read anything about DeFi or try to understand DeFi. So ERC20 token standard is, the idea was that when we say a fungible token, then we need to have a token which has got a defined standard, right? So that if there is a standard that this is portable, it can be moved from one place to another. To take another example, let's say in the case of healthcare, just imagine there are hundreds of different healthcare platforms which are keeping your data, health data. including your personal details and health details. Now, just imagine you are somebody moves from one medical practitioner to another medical practitioner, maybe for a second opinion, maybe for a subsequent checkup, or maybe for a different problem altogether. Now you want to bring the previous history to the new practitioner who may be using a different system. Now, these two systems do not understand each other. Their database schema will be different, right? So then they cannot talk to each other. For that, we need to have a common standard. Once we have a common standard of data, how the data will be stored with the common label types, then this data becomes portable across two systems. In the same way, in Ethereum, we wanted to have a token standard so that once that you follow that standard, then your token can be portable from one contract to another, or can be understood by any contract. So in the same way, ERC20 actually defines that standard. So any token which has been formed using the ERC20 standard, that means it defines the fields, like there is a field for total supply, what the total supply of that token will be when you define it. Or there's a transfer function that define how the token can be transferred. Then there are some additional functions like balance of. Balance of shows that for a specific address, what is the balance of this token? Or there is a function of approve. So sometimes what happens is you give approval to some other address. So let's say in your wallet, you have got 100 tokens of a specific type. You can give authorization to another user to spend those tokens on your behalf. That is governed by the approve function. So these are some of the standards which are defined. If you follow that standard, then token can be exchanged with any other token of the same nature, ERC20, on the same Ethereum blockchain. So that is the major value of having a standard. And there are various other types that is based on business use or business utility. So there are, I'm covering 3 types, but there are many, many more types now. So primarily being equity token, utility tokens, and governance tokens. And some of the tokens can be used for one or multiple purposes also at the same time. So let's talk about equity token. Now, equity token is a token which represent an underlying asset or a pool of assets, right? In some cases, it can also be called asset-backed token. So for example, your gold tokens. Now in gold token, what happens is, let's say you say that I'm creating a new token, which is ERC20 standard. Each token is backed by 1 gram of gold. So now your token is an asset-backed token, and each token will derive its value from 1 gram of gold. So the price will not be stable. As the price of gold changes, the price of token will also change. But the underlying asset will be pegged 1-to-1 in the sense that 1 token will always be equal to 1 gram of gold, whatever may be the price of that gold, right? It may be other pool of assets, like, for example, when we talk about liquidity pools, you provide liquidity in terms of tokens to a pool. Like, for example, in Aave lending pool, let's say you deposit 1 Ether, then you get liquidity provider tokens in return, LP tokens. So, so that LP tokens represent your stake in that liquidity pool that you have deposited. It's like a receipt that you have deposited. When you do a deposit in your fixed account or fixed deposit, you get a receipt which shows that, yes, you have a deposit in the bank of this amount. So that receipt is like a token here, which represents what asset holding you have under that. So those are called equity tokens. Typical use cases, as I mentioned, in the case of providing liquidity anywhere, whenever you provide a liquidity, they return a liquidity token back to you. So that that shows that you have a token which represent an asset there. As I mentioned, asset-backed tokens are another example, a token which is backed by gold, or it may be traditional equity shares also, if a token is backed by, let's say, an equity share. So that is also happening, which are typically called security tokens also, when we talk about specifically traditional equity. But largely the idea is equity here means that you have ownership of an underlying asset or a pool of asset. And it may have various use cases in the case of governing profitability or voting also. So for example, let's say there is a investment smart contract where people are pulling in money and different people are pulling in different set of money into it. And once they put in the money, there's a proportion, how many, which person has put in what kind of money. So based on the proportion, a set of tokens can be issued. So let's say we create a pool of 100 Ether, or let's say $1 million. Now, and there are 10 people who have contributed funds. Now, in lieu of that, in lieu of this asset pool, we created, let's say 1,000 tokens. Now, 1,000 tokens correspond to $1 million. And let's say if I contributed $500,000 to it, then I will be given 500 tokens that represent this $500,000 equity. So this is how it works. And then based on this token, I may have different rights because I have contributed more to the contract. So let's say this fund is going to be deployed to give startup funding to startups. So I will have more say because I have contributed more. Or let's say this is deposited somewhere in bank and bank gives an interest. Now that interest can also be proportionately divided among all the stakeholders in the contract based on how many tokens they are holding. So here the tokens make it very easy to see what ownership you have within the pool, and if there is any future cash flow in the terms of dividends, interest, profits, anything can be divided based on how many tokens you are holding. So let's say there's a profit of 100 tokens. Now we know that there are 1,000 tokens altogether. So 0.1 token out of that profit will go to each token holder. So it becomes very easy operationally also. The second type of fungible token are utility tokens. And they are very important because utility token, security token has been a long debate, especially in quite a few ventures. The idea of utility token is that the token should be utilized or have a clear utility within the platform. So if you take the largest examples being the blockchain protocols itself, Ethereum protocol itself. And on Ethereum, if you remove the Ethereum token, the platform will not work because all the incentives, all the fee collected is in Ethereum. All the incentives given to miners are in Ethereum. So if you remove the Ethereum token out of Ethereum blockchain will not function. So that means this token is utilized properly within the system. It is part of the ecosystem. And it is not just being utilized. It also captures the enterprise value of that system, the token. So as more and more Ethereum is being used, more and more gas fee will be accrued, more and more miners will participate, the ecosystem will grow, and the value of, as the demand of token will increase to pay the gas fee, more the price of Ether will go up. So that means it is not just being utilized into the system, it's also capturing the essence of the value of the ecosystem. And then utility token are also, used to for other purposes. For example, in the case of synthetics protocol, it is being used as a collateral. And in the case of, this has been done in the centralized exchanges also. In Binance, you can actually pay some of the fee in BNB. Similarly, in the case of decentralized platforms like DAI, MakerDAO, etc., you can actually pay application-specific fee within the native token. So idea is how to bring in more and more utility so that the platform is powered using the utility token. The third is a governance token, as the name suggests. Again, as in the previous example, I own 50% of the tokens because I contributed 50% of the funds. Now, it may further extend it that since I own half of 50% of it, then if there are voting rights or there's some decision making that needs to be done, then I should have 50% of decision making or some disproportionate decision making. So whenever tokens give you rights, voting rights, then they are called governance tokens. And DAOs, or there are quite a few DeFi protocols, and more DeFi protocols are now, in fact, they always wanted to have a governance token to start with. But as we know that the growth of DeFi, happens over a period of time. Initially, it's more of centralized, and slowly they are becoming more and more decentralized. One example I'll repeat later also, but I'll give you right now a classic example of voting rights. We know that when you write a smart contract, there may be two challenges. One, the smart contract may have a bug that needs to be fixed. So typically, smart contract was once deployed cannot be changed, right? So there are two challenges here. One, it can only be changed by the smart contract admin itself. But that goes against the whole philosophy of decentralization. Because if only one person has got access to change the smart contract, then it becomes pretty much centralized. The second is, still we need to have, we will have scenarios where the smart contract needs to be changed. Either there is a bug that needs to be fixed, or let's say from time to time have changed, some policies have changed, the smart contracts need to be upgraded. But if these two scenarios, having a bug that needs to be fixed, or some future changes in the environment, maybe socioeconomic, technical, or whatever, the smart contract needs to be updated. In both these scenarios, we cannot give access of changing this to one smart contract admin. So to make it more decentralized, these governance tokens are used, where anybody who is owning the token of that specific application, for example, let's say you are invested into Aave. Now, Aave protocol is led by Aave governance token. So if you own the governance tokens, then you would be voting on which changes need to be done in the smart contract. And based on the your voting, the decision will be taken whether to make this change or not. DAO are clear examples of this. All the DAOs, the central piece is this only. Then when you're part of a DAO, which is decentralized autonomous organization, based on your holding of your tokens, you vote on different decision making. In the case of DAO, we are extending not just to make changes to the smart contract, but the essential function of an organization itself. So if let's say the function of a DAO is to make investment into startups. So which startup to invest in, which startup not to invest in, that decision can also be taken using voting rights in the case of DAO. But here in DeFi, about what I'm talking specifically is about the smart contract changes. So for that also you require governance, a decentralized governance, and the decentralized governance is done in the form of using the governance tokens. So this was fungible tokens. I think there's one question. Let me see. Sorry. Okay, so question was, how do miners select transactions that need to be validated, or is it delegated to them? No, it is not delegated to them. Transactions are, people are doing transactions. They keep on coming into the mempool. And so mempool and the miners in their full node that they have deployed, they can see all the transactions and they validate. So they ideally, in an ideal scenario, they'll validate each and every transaction. But what I meant was that there's a possibility that they may choose not to if the fee is low. Because see, if you see, you can compare this fee to an auction. So actually, when you are putting in transactions to a mempool for a miner to see and validate and put into a block, the whole concept of gas fee is like an auction. So you are paying gas fee, and people who pay more gas fee will be picked up first. And it is actually behaving. And that's why sometimes you see when what happened in the case of CryptoKitties in Ethereum, and in last year also, it's only recently, last 2 months, when the gas price has dropped, has become very low. But even before 2-3 months and last year, the gas price was huge because there was a lot of congestion on the network. By congestion, I mean that more and more transactions are coming in, and because each block is written every 6 seconds, so that is defined, right? And each block has got a definite size. So that means that one block can consist of a certain number of transactions only. So that's why this auction kind of scenario comes in. Since only a block can be written only every 6 seconds, and only a fixed number of bytes can be embedded into a block, limited number of transactions can be embedded. So that's why this happens that, if you pay more gas fee, your transaction will be liable to be included. Coming back to non-fungible tokens. So that we covered was fungible tokens. Non-fungible tokens, I think, are much more popular. I'm sure you must have heard about it, interacted with it, purchased it, whatever, or invested into it. So non-fungible tokens are tokens which are basically not interchangeable. They are unique and rare. So any token which represent, let's say, for example, collectibles or digital art. Now, each art is different. Each avatar is different. So that's why what you require. So now let's first see, we talked about the standard of ERC20, which was a fungible token standard. Now we do require all those standards in the case of non-fungible token also, but we require some additional pieces. One additional piece is we require metadata, because in the case of non-fungible, we are saying that the token is non-interchangeable, or the asset that the token is representing has got some unique values. So those unique values also go to need to be there. So that is the metadata part of it, the uniqueness part of it. Second, in the case of non-fungible tokens, what happens is, let's say if I've got 100 USDT, I can simply transfer 80 USDT to you. Now this 80 USDT are transferred as a bulk, because there is no unique identity of each USDT in the wallet, because they are fungible. In the case of non-fungible, each token will have a unique ID, asset ID. So if you go to a Etherscan or any browser, you will see an asset ID is being allocated to each token. So if you have 50 non-fungible tokens, each will have a unique ID. If you see any of the 10,000 avatar projects, each 10,000 of the assets have got a unique asset ID. So these are some of the variations in the NFT standard. The standard being used in the case of NFTs is ERC 721. Which uniquely define each kind of asset. But then there are some special cases. So first, let me talk about 721 itself. So 721 is the most defined standard, and some variation like 721A to reduce the gas fee has come up. And it defines the non-fungible asset, that the asset is not fungible, it cannot be transferred or interchangeable. Now, non-fungible tokens are backed by non-fungible assets. What we see on OpenSea, etc., digital arts, or any kind of digital, maybe video or music or audio or domain names, etc. But now the concept of non-fungible tokens is not restricted to just digital collectibles, but it is expanded to the traditional real-world assets. So now if you can tokenize real estate property into an NFT and then sell it, or carbon credit certificates, or it can be bonds, or it can be loans. Each loan has got a specific metadata, right? So if you have a loan, there's a specific metadata, when it was taken, how much the loan was taken, what the terms of the loan were, what like the interest rate, tenure, etc., and what the future cash flow will look like. So this loan can be tokenized into an NFT and then traded in the market, a secondary market. So non-fungible token is something very big. Right now, what as a normal user we have seen in the market, what we have seen is just the a small part of it, which is the digital collectibles. But the concept of non-fungible token is expanded huge now, where we are talking about real-world asset tokenization. There's another standard related to non-fungible, which is 1155. This standard came in because there are few use cases where you require a mix of fungible and non-fungible. So so that's why you have a 1155, where you can have a bunch of fungible and non-fungible. So we use that ERC 1155. One classic example is, let's say, carbon credits. So each carbon credit is equivalent to 1 ton of carbon dioxide. And ideally, each carbon credit certificate has got a unique serial number. So there's a unique NFT belonging to it. But when a project get carbon credit issued based on a project, the carbon credits may be issued in bulk, let's say 1,000 carbon credits or 10,000 or 50,000. And then they are being sold or redeemed in again a bunch. Somebody wants to buy 2,000 carbon credits. So using 721, I actually need to do 2,000 transactions, because in 721, each carbon credit will have a unique identity and 2,000 transactions will happen on blockchain. It does not make any sense, because their value is same, their price is same, the price does not vary. Yes, the serial number is different, So in that case, we use 1155, where we create a fungible, non-fungible token, and within non-fungible, the copies of the non-fungible token are fungible with each other. So there are quite a few use cases where we use 1155 instead of just using 721. Okay. So I hope fungible and non-fungible tokens are clear. If there's any question, do let me know. Now I move to a very one of the very critical component of DeFi, which is custody. So I briefly talked about, when we talked about ERC20 standard, we talked about an approve function, right? So with that approve functionality is that you hold the tokens. So the tokens are still in your wallet, in your custody, but you have given the right to someone else to spend those tokens. But till the time those tokens are spent by the approved user, the tokens are still in your custody. So that is a typical of ERC20 interface. ERC20 standard, the approve function behaves like that. But then there are use cases where you need to give a full custody. For example, the classic example is a swap case, right? So when we say if you want to exchange something with other, there's always a challenge that who is going to give the asset first. So if I have an asset A, you have an asset B, and we want to exchange that, interchange that. Now, if I give my asset A to you, you may refuse to give your asset B to me. Now you have both A and B and I have nothing, right? So in traditional world, we use an escrow company. We need a mediator who is facilitating this transaction. So what will happen is there's a mediator. I will give my A asset to the mediator. You will give your B asset to the mediator. Mediator will then exchange it, right? In the case of smart contracts, the smart contract itself is acting as that mediator. And these are called custody contracts or escrow contracts. So for example, in the case of DeFi, or you can say NFTs. So you have an NFT, you are putting that NFT on sale on OpenSea. Now you say that, okay, I have this NFT and I want to sell it. And I want to sell it for, let's say, 1 Ether. Now you need to put that NFT into the custody of the smart contract, because it may happen that I have put in 1 Ether to buy it, but you say that I won't give my NFT. I've already sold it to someone else, right? So that's why custody happens, that whenever a proper, fair and transparent transaction needs to happen, especially in the case of swap, the example that I gave, both the parties will put the token into custody, and then the smart contract will facilitate the interchange or exchange. Apart from this, collateralized loans. In the case of collateralized loans, on one side, you have lenders, liquidity providers, who are providing liquidity, or they are lending an amount to the smart contract, or the liquidity pool, as we call it. And so those tokens that I have provided as liquidity will remain in the liquidity pool. So that's a custody contract. They will remain in that custody, and then borrowers can borrow them. So these are some of the, so pretty much you will see that custody is very important, as you can rightly understand, that it ensures that, you know, a fair transfer can take place, or a fair transaction can take place. So custody again, but you know, when we talk about burn function, I'll explain this further. But you can understand, let's say you put a token into a custody, and if the token, the smart contract does not have a proper way to retrieve that, it may be possible that the token becomes useless, because it can go into a permanent custody and there's no way to take it back. So whenever a smart contract is written, and if it has got a custody function, then it also will have a function to ensure that, you know, it can be taken back from the custody based on certain rules. So for example, in the case of lending applications like Aave, Compound, etc., what happens is, let's say you're a liquidity provider and you want to provide liquidity to a liquidity pool contract on Aave. So you're putting a liquidity of, let's say you have got 10 Ether with you and you have no use, you don't want to sell it. Still they are lying in your wallet, so you want to invest them. So you put that 10 Ether into Aave liquidity contract. So Aave will give you in return 10 LP tokens that will represent that you have given 10 Ether to the pool. And 10 Ether will go into the custody. And you will have these 10 LP tokens as a form of receipt. Now, whenever you return these 10 LP tokens back to the liquidity pool, you will get your 10 Ether back. So that is how it works. But if, let's say, a proper function has not been written, when you return your LP token and the contract, there's no function to return back your liquidity. Liquidity will be logged into the contract, right? So there's a risk of permanent custody if the a proper method or mechanism has not been defined in the smart contract. So that needs to be defined properly. So that was custody of tokens into a contract. Now we talk about the supply adjustment. Supply adjustment, I'll talk about two pieces, which is minting of new tokens and burning of tokens. So the terms are self-explanatory in the sense that when we talk about minting tokens, new tokens are being minted. It's like new currencies being printed by the central bank. Now, there may be various use cases why new tokens are being minted. So let's say somebody is giving rewards, like for example, Pancake Swap. They give staking pool rewards or farming yield rewards by minting new tokens. If you see blockchain outside the DeFi applications, if you see blockchains also, the miners or the stakers or the validators, they get rewards, and the rewards are by freshly minted tokens. So in the case of Bitcoin, every 10 minutes when a new block is written, the miner who has written the block get the freshly minted Bitcoin tokens. And if you are creating a ERC20 base token of yours, again, you will be minting tokens. So minting is that function. So it may be minted on a based as a reward, or to bring in inflationary trend, or for any kind of incentive within the platform. The opposite is the burning. So burning is where you actually want to burn the tokens so that it cannot be used. In traditional way, like typically fiat old notes are being burned so that they cannot be reutilized in the circulation. Similarly, in the case of DeFi, we have a burn function. Now, in DeFi, how the burn happens is either you send it to a wallet where there's no owner of that address. So there are some burn addresses. Nobody owns those burn addresses. And there's no private key associated with those burn addresses. So if you send tokens to those burn addresses, they are lost. They still remain there, but they are, for all practical purposes, they cannot be spent. Or there are specific smart contracts where you can send the tokens and they become unusable. One example I gave was the risk of custody, where you put some tokens into a contract, but there is no function written to take it back. So they are as good as lost. So there are smart contracts, also burn contracts you can write down, where there's one way of sending tokens to the contract, but there's no way of retrieving back. So now why burning is important? Because one, a lot of protocols do burning for deflationary reason. For example, Ethereum launched EIP 1599 last year, that bulk of the fee that is being generated in transactions will be burned rather than giving to the miner, right? So, so that will reduce this number of tokens in the circulation. So, and that will cause deflation. So one is deflationary reason why the tokens are being burned. Another example could be redemption. So let's say we talked about gold tokens, right? Now each token is backed by 1 gram of gold. And let's say I want to redeem my physical gold. I have got 100 tokens and I want to say that I want gold now. So I go to the gold vault, I give the 100 tokens, and a physical redemption happens. They give me 100 gram of gold in physical form. Now what to do that 100 tokens? Now they don't have any underlying asset anymore because I've redeemed the asset. So then those 100 tokens will be burned. So redemption use cases is a very classic use case. The another use case which I talked about in the case of lending protocol like Aave or Compound, the LP tokens which I got after giving my liquidity to the pool. Once I give my LP tokens back to the pool will return that 10 Ether back to me. But what it will do with that LP token? It will burn it, because those LP tokens cannot be used again. It was a receipt. So you made a deposit to the bank, you got a receipt. Once you take out your deposit back, obviously that receipt has to be given to the bank, and bank is going to cancel it so that it cannot be used again, right? Same way. So redemption, deflationary reasons, these are some of the reasons. This third very interesting topic is bonding curve. Today we don't have much time, and it's a bit complex, but I'm in one of the next session, I'll be covering market making in detail, the automated market maker algorithm. There we'll talk about the bonding curve, how it works. And it's a very interesting topic. Somebody who wants to actually innovate in the DeFi space, especially on the lending side, there's quite a few interesting areas that have opened up based on yield, especially variable interest rate, and so on and so forth. So there, the understanding of bonding curves, how AMM works, etc., becomes very, very, very handy. So I'll come to incentive, and then we have a few more topics. So I'll be a bit fast. So incentive is very clear. I think we have pretty much covered with various examples. So by incentive means so there's an incentive and disincentive both. So that's the economic side of a blockchain-based or a decentralized ecosystem. Like in the case of staking and mining, they are incentives, right? So incentives or disincentives are to encourage or discourage a specific behavior, right? So in the case of mining and staking, what happens is they are doing the hard work, they are solving the puzzle in mining, they are putting in a stake in the case of staking, so they get a reward at the end of it for the hard work that they have done or the risk they have taken. So that is this, and then there are staking pools. So if you go to Uniswap or PancakeSwap, or you put some money into the pool, and you are giving incentive, you are given interest. Similarly, in the case of lending pools also, if you are providing liquidity, you are gaining interest. So that's an incentive of putting in the money. So those are staking rewards, right? On the disincentive side, one of the common is staking algorithms. So Ethereum, as you know, next month is moving from proof of work to proof of stake. Now in staking, what happens is you put in a stake. So Ethereum requires, let's say, 32 Ether as a stake. You put in 32 Ether into the contract, and based on the staking, if you win, you get a reward. Now, let's say if you are, being biased, you're making some changes, you are doing some wrong activities, or the node that you have deployed for staking, it's not up. There's uptime has got a lot of problem. It's down 5%, 10% of the times. Or it is acting very slow. So there are defined set of parameters which says that if any of these things are found, that means you are not doing your job properly, and whatever tokens you have staked will be slashed. By slash means they will be confiscated. They will not be given back to the users. So this is a form of penalty or a disincentive that is applied. In the case of collateralized loans, we'll quickly cover that in the next slide. In the case of collateralized loans, let's say you have taken a loan, you have given a collateral. Now the value, and let's say it's very simple that you have taken, let's say, a loan of 100 rupee, you have given a collateral of 100 rupee. And in collateral, let's say you have given real estate. Now the value of that real estate dropped to 80 rupees. Now you have got more loan than the collateral that you are providing. So in that case, liquidation can happen. The property can be liquidated, and so that is like, again, a disincentive. So liquidation becomes a disincentive. And there are direct rewards and keepers. Some of the platforms, they reward their users. Like Rarible did a very interesting thing when they launched. Rarible is, again, one of the largest NFT marketplace. They did an interesting thing that every week they set aside as a number of tokens to be given as rewards to early adopters of the platform. And this reward will be given for next 3 years or 4 years. So the early adopters, I mean, they used to calculate every week who has done most transactions, buy and sell transactions on the NFT marketplace. And based on that, a portion of the token will go to them as a reward for being the early adopters, early users of the platform. So you are rewarding in the form of users. Swap is that we discussed briefly about is a very important function where you are changing one token against another. One straight example is the decentralized exchange, where you are exchanging one token with another. Earlier, there were centralized exchanges where you deposit a token. If you want to buy another token using your existing token, you can do that. Decentralized exchanges came in that they are completely non-custodial. There is no intermediary. Nobody is holding your funds. There's an escrow contract. You put in your funds there and you get the another token in return of that. I won't go into detail of automated market makers, but I'll just briefly tell that there are two approaches to a decentralized exchange. One is the order book based matching algorithm. Now that is very similar to a centralized exchange or how our stock exchanges work. You go on a stock exchange, you put a buy order that I want to buy, let's say 10 shares of TCS. And there's a sell order who wants to sell 10 shares of TCS. They are going to be matched with each other and the trade will be executed. So that's called order book based matching algorithm, where there's an order book, there's a sell order book, there's a buy order book, and the orders are matched with each other. And if they match each other's requirement, the matching is done. But then there are challenges in order book based when we talk about a decentralized exchange, because somebody is providing the liquidity for this to happen, and there may be no takers. So there's a person who has put in the sell order, but there's no buyer. So for that, a more efficient and better way was automated market maker based, called AMM. So AMM based algorithms came in, which is again, AMM is a smart contract, which basically puts automatic buy and sell orders both on a pair. So let's say you want to buy USDT out of Ether or Ether out of USDT. So for Ether USDT pair, the AMM, the smart contract has got liquidity, and they put in both the buy and sell bids and execute the order. So all the dexes today, whether you talk about Uniswap or PancakeSwap, SushiSwap, or all those are working based on AMM based algorithms. Now AMM itself is a much larger topic. We'll cover it in the subsequent workshop. Here the need to understand is that now you have AMM based, it's a completely non-custodial exchange, and there is a risk of impermanent loss. Again, I'll cover it that later. But the exchange happens almost in real time. You get very competitive rates, because if the rates is not competitive, there's always arbitrage opportunity, and the rates will automatically settle down to be the most competitive rates. Today, we have a lot of DEXs. There's a direct integration of swap function within MetaMask and various other wallets. So it's very interesting. You can buy one token, sell one token, buy another token almost instantly using a swap function or decentralized exchanges. A brief on collateralized loans. So collateralized loans is I think, as you know, lending is one of the core banking function in the financial world. Similarly, in the case of DeFi, of course, lending is one of the most important function. Now, as you can understand, it is transparent, it is non-custodial, there is no intermediary. So, of course, unsecured loans cannot happen through a smart contract, because people will just take a loan and will never repay back. So all the lending protocols, whether it be Aave, Compound, and there are quite a few which have come up now, they work on a collateralized loan kind of concept. And as you know, the value of gold or real estate is not that volatile. But as compared to that, the value of crypto tokens are quite volatile. So that's why the collateral that you need to provide to take a loan is quite more than what you are borrowing. For example, let's say you want to borrow $100 worth of asset or token. You need to provide collateral up to $150 worth of token, or 200, or even 300 in some cases. If the token is very risky or highly volatile, this is called collateralization ratio, how much collateral you are providing to take a certain loan. So if you're taking a loan of $100, putting in 150 worth of collateral, that means, your 150% is the collateral, or 1.5 is the collateralization ratio, right? It may go up to 200%, 300% also, depending on this. And the concept is very clear. So let's say if you have given Ether, you have got one Ether, you have given it, let's say assuming the price of Ether today is $2,000. So if you are giving one Ether and the collateralization ratio is, let's say 200%, then by giving one Ether, the maximum you can borrow is 1,000 USDT. And the idea here is that if the value of Ether goes down tomorrow to, let's say, 1600, 1500, or 1300, still, your collateral is covering your borrowed amount, right? So that's why in collateralized loans, collateralization ratio or percentage is very important. But even if with a higher collateralization ratio, still liquidation can happen. Sometimes we have seen that the crypto market has crashed by 200, 300% also, right? So for that, then there are liquidators. So in that case, what will happen? So let's say we define a margin requirements, very traditional to a traditional lending also. There's a margin in traditional lending. So here also we define a margin. So taking the same example, the value of Ether is 2000 today. You have taken a loan of 1000 USDT and we define the margin to be 1.2. So if the value of Ether goes down, till the value of Ether goes down till 1200, you are safe. You're covered. But if the value of Ether goes below 1200, 1199 or 1150 or whatever, then your asset can be liquidated. So you will be given an alert that you need to put in more collateral. So you can put in 0.1 Ether more, so that another $100, $200 worth of Ether you can put in more. Then the loan will continue. But if it falls below 1200 and you have not put in more collateral to cover it, then there are third-party liquidators who can liquidate your position. So they will sell that Ether at 1150. They will 1000 USDT you already have. They will give you 150 worth of USDT and your loan is closed. So that's how loan closure happens in the case of crypto-based collateralized lending, like in Aave or Compound, any of the platform. This is how the process works. So this liquidation is a very important part of it. And these liquidators, they are incentivized to do it. Now, what is the loss here? Because you never wanted to sell Ether. So you will see that, okay, even if liquidation happens, I as a borrower have still got, my value, right? But that's not true. One, the liquidators, or also called keepers, they are going to charge a fee on liquidation. So that is your loss. And the second is, you never wanted to sell Ether in the first place. That's the reason you took a loan against it. If you would have wanted to sell Ether, you would have sold it for $2,000, on the day of you taking the loan, rather than putting it as a collateral, right? One needs to put a collateral because they don't want to sell it. They want to retain that collateral for a longer period of time. So, so that's the concept of collateralized loans, where you put in a collateral. There's a liquidation, there's a over collateralization ratio based on which you put a collateral. And that collateralization ratio varies from pair to pair, again, depending on how stable, mature the token is. New tokens, of course, are more risky. We don't even know whether those tokens will become shitcoins, right? So nobody would be able to, most of the platforms won't even take them as collaterals. So all those are very, very logical extension of how traditional lending happens. And yep. So this is, I think, in a short, very short, but yes, we'll have a separate session where we'll deep dive into each specific areas, now use cases based off sessions. For example, one of the session will be purely on lending and borrowing. So we'll discuss Aave in full details. We'll also discuss, some of these various aspects, how liquidation works, how collateralization works, and, rest of these pieces. Small mention on flash loans before I close. So this is very interesting topic. So as I mentioned, uncollateralized loans normally doesn't happen, right? It does not make any sense, because I can keep on borrowing. Nobody knows me. In a DeFi world, I'm anonymous, pseudonymous. Nobody knows me, I can keep on borrowing. So uncollateralized loan don't happen. But there's a very interesting flash uncollateralized loan happen. And this uses one core property of DeFi that we talked about in the last webinar, which is atomic swaps. And which I mentioned that, in a smart contract, let's say there are a set of 5 transactions that are going to happen. A transaction A to transaction E. And in the end, what needs to happen is, so let's say there's a very simple transaction. Somebody is giving asset A to asset B. Asset A one person is holding, asset B is another person is holding. They want to exchange this. Now there can be a simple swap. But let's say before this swap happens, there are various other pieces that need to happen. Other transactions need to happen. So let's say the same transaction is happening between 4 people. So first person will give the asset A to second person will give it to third person will give it to fourth person. The fourth person will give the asset B back to third person, and third will second, and second to first. So let's say instead of simple one transaction, it may be a set of 6, 7 transactions. The beauty of atomic swap is that even if one transaction fails, let's say the third person does not give the asset A to fourth, the whole transaction will be reversed as if the transaction never happened. That is the beauty of atomic swaps. That brings in the atomicity. That if there is a transaction which has got multiple steps, even if one step fails, each step which has been executed will be reversed as if those steps never happened. So, and that gives rise to one very interesting use case of uncollateralized loans, that you can take an uncollateralized loan, but you have to return that loan within the transaction. So let's say there's a transaction, you may take a loan at the start of the transaction, you may do something with that loan, and then within the transaction, you return back the loan. Now, since this is an atomic swap transaction, there's one full transaction where you have taken the loan, you have returned it, you do not require a collateral. But if you do not return it, then the whole transaction will be reversed as if you have never taken the loan. And this is typically used for, making use of arbitrage opportunity. For example, you go to you take a DAI. DAI is a stable coin, which is basically a crypto collateralized stable coin. So you take a DAI flash loan, uncollateralized, a big 1 million of DAI you have taken as a loan without giving anything, right? No collateral. And then you had an Ether vault with MakerDAO. So you deposit those DAI into the Ether vault, take the Ether. So you will get your Ether back. Now you go to, you sell your Ether and take BAT, a basic attention token. It's a type of token. And then, you open a BAT vault in MakerDAO. You will get your Ether DAI back, and then you give your DAI back to the flash loan is returned. So what you have done is you have taken a loan, you have returned the loan at the end of the transaction. And in between, you have used that loan to do a transaction. You have taken Ether, you have sold the BAT, and then you have deposited the BAT because you found an arbitrage opportunity that you want to leverage it. So sometimes you have arbitrage opportunity where if you have liquidity, you can make use of that arbitrage opportunity, right? So that is where, flash loans become very important. Yeah, so there's just a brief on the architecture, but let's skip that. So DeFi is very interesting. Decentralized finance is growing very rapidly, and especially with newer and newer products. Now, today we have DeFi apps, which pretty much cover all the traditional financial products. Lending, you have seen. Exchange, you have seen decentralized exchange. Staking products like fixed deposits, and wallet transactions were already there, send and receive. But apart from that, now we have decentralized insurance like Nexus Mutual, or there are quite a few others who are right now again insuring the smart contract hacks, but they are completely decentralized, where there's an insurance pool, and then there's a premium, and then based on smart contract, the claims are settled. So now DeFi is pretty much covering all different financial products that we see in the traditional financial world, including banking products or insurance products or investment products. DeFi has been growing very rapidly. Crypto winter is going on, but still that just says that, the value of total value logged in the DeFi goes down, but that's a temporary phase. But what we are talking about here is not what is happening on the liquidity, or we are talking about the technology per se, or the value this technology is bringing into the decentralized world. And just imagine lending happening in almost real time without any intermediary. It's so amazing as compared to what traditionally we have been used to. Thank you. Any questions? So in the next webinar, we'll start deep diving into specific use cases and a brief on, how DeFi is solving some of the challenges of CeFi, centralized finance. And we'll talk about some of the use cases. Largely, we'll cover lending, borrowing. We'll cover some of the investment use cases, DEXs, and then, maybe decentralized insurance, etc. Thank you. Thanks, Aminulli, for your comment. So if there are no questions, you can always, I'm the co-founder CEO of Zeeve. Zeeve is a Web3 infrastructure as a service platform. We provide nodes, full nodes, archive nodes, developer APIs for anybody who wants to connect to blockchain, use the APIs into their decentralized applications or other blockchain applications. And you can always follow me on LinkedIn. You can follow Zeeve on LinkedIn and join our meetup and Telegram group to stay in touch with us. Thank you.